this graphing inequalities and looking at solutions. If you had a problem like this, you would graph first. So we know that if we plug in 0 for x, 2 times 0 plus 5, this is one way to do it, would be 0, 5, right? That would be in an ordered pair. If, let's say, we plugged in 1, 2 times 1 plus 5 would get us 2 plus 5, or 7. So 1, 7 would be an ordered pair. So you come over here, if I'm counting by ones, 2, 3, etc. If I count by ones on the y-axis, then I would graph 0, 5, 2, 3, 4, 5, and 1, 0, 5, and 1, 7. So let's say 1, 7 is right here. And because of the inequality symbol, it would be open circles and dotted lines. So I would now make these open, and I do dotted line. And then you would test a point on either side. Doesn't matter which point you test. So I would test 0, 0, because it's far enough away. So is 0 less than 2 times 0 plus 5? Is this true or false? Yes. So yes means shade. Solutions are in the shaded region, right? So here are solutions. Non-shaded are not solutions. So if we look over here, ask ourselves, is 1, 2 a solution? 1, 2, yes, is in the shaded region. Yes. Is negative 5 negative 3? Negative 5, negative 3. Well, if I'm not sure, I can always plug it into the inequality. So is, if y is negative 3, is negative 3 less than 2 times negative 5 plus 5? Negative 3 less than negative 10 plus 5. Is negative 3 less than negative 5? So if negative 5 is here in the number line and negative 3 is here, negative 3 is actually bigger, right? So no, that would not be a solution. 0, negative 1, yes. 2, 9. Now 2, 9, I'm not actually really sure, so I'm going to test 2, 9. So let's test 2, 9. So I'm going to put in 9 for y, less than 2 times 2 plus 5. So this would be 9 less than 4 plus 5. Is 9 less than 9? No, it's not less than. So we cross off. So the only two solutions would be 0, negative 1, 1, 2. You can look in shaded region, or you can plug in. Now let's look at the second one. When solving an inequality, flip an inequality sign when multiplying or dividing both by negative. Yes, that is true. So for example, if you had negative 2y is less than 4, if you divide both sides by negative 2, you'd have to flip the inequality symbol. So y is greater than negative 2. That's what that means. So let's look at the next one. If you're given a graph and you want to find the right equation, first of all, we know, because it's a full line, we know it has to be less than or equal to or greater than or equal to. It can't be these, because those would be dotted bounds. Now let's look for the y-intercept, where it touches y-axis. So it looks like, if we're counting by 5s, 1, 2, 3, 4, 5, it looks like this spot is 1, right? So the y-intercept is 1. In y equals mx plus b, that last spot is the y-intercept. And let's look for the slope. So if I start here, I go down to right 1, down to right 1. So I know it's negative 2, down to right 1. So my slope is negative 2. Now that makes sense, it's negative because my line's falling. So we know it's got to be y, we know m, x, and b. Now right now, I'm not sure what the inequality symbol is. I know it's got to be less than or equal to, greater than or equal to. I'm going to test a value. So if I know that 0, 0 is shaded, I know that when I plug in 0, 0, I should get a true statement. So let me try. Y is less than negative 2x plus 1, and y is greater than negative 2x plus 1. Let's plug 0, 0 into both. So if I plug 0, 0 in, which of these is true, right? 0, 0 should be true because it's shaded. So 0 less than 1 or 0 greater than 1. Well, if it's supposed to be true, I know 0 is less than 1, so I know it's got to be y is less than negative 2x. And we write or equal to, because it's a closed bound. So for this one, we would pick less than or equal to. So we'd pick this one, the yellow. Okay, let's look at the next one. So for this one, if we had to go graph, first of all, we know that the slope is negative. So we know our line's falling. So this is rising. This is rising, right? You're heading up. These both are falling. So we know it's either the yellow or the green. Now if we went to graph this, we know that 4 is the y-intercept. We know this is the slope. So if I went to graph, let's say I was counting by ones, 2, say that was 3, say that's 4. I know it's going to be closed circles. The slope is negative 1/3. I'm going to go down 3, down 1, 1, to the right 3. 1, 2, 3, closed circle. Down 1, 1, 2, 3. And it would be closed. And then I could test 0, 0. So is 0 greater or equal to negative 1/3 times 0 plus 4? Is that true or false? Well, that's false. So I wouldn't shade this side, I would be shading the other side. So I know it has to be the green. Now this one. I know because of the inequality symbol, it would have to be dotted. Now I know we can't really tell down here if they're dotted, they're too small to see, and I know I'd have to have open circles. So for this one, I'm going to find the x and y intercepts. So for the x-intercept, I know if I plugged in 0 for y, I'm going to pretend that says equals, I would have x-intercept around 3, or at 3. My y-intercept would be 2 times 0 minus 3y equals 6, cross, divide by negative 3. So y, negative 2. So let's look over here. Y would be negative 2. Okay, this looks like y could be negative 2. This doesn't look like that y value is negative. That y value is positive. Over here, this y value is negative, so that's still in the running. Over here, this y value is positive, so that's out. X value of positive 3. This looks like it could have an x value of positive 3. This looks like it could have x value of positive 3. So we know the red and the yellow are still in the running. We need to see shading. So if I was to go and graph, and I said x was 3, 1, 2, 3, open circle, y was negative 2, 1, 2, dotted, I could test 0, 0. So is 2 times 0 minus 3 times 0 greater than 6? 0 greater than 6? False. So false means don't shade. Shade the other side. So between red and yellow, it must be the yellow one, based on the shading. Oops. Okay, so let's look at this next one. We know that we have 0, 0 should be true statement because it's shaded. So 0, 0, if I put 0 in here, I'd have 0's greater than negative 10. 0, 0 should be a true statement, so that's in the running. If I plug 0, 0 in here, true. If I plug 0 in here, 0 less than negative 10, false. it's out. Is 0 less than or equal to negative 10? That's false, it's out. Okay, look at the inequality symbol. The bound is closed, so I know it's got to be this one. I could plug in to find intercepts. The y-intercept should be negative 2, check, and then the x-intercept should be negative 10/3, check. So for this next one, first of all, I know 0, 0, if I plug 0, 0 in for both of these. Is that true or false? Is 0 less than 16? So is 0 less than 16 true? So I know 0, 0 should be shaded. 0, 0 should be shaded. So by looking at this, I see that for the blue, let's wait till it stops moving. For the blue, 0, 0, oops. 0, 0 is not shaded, and we said 0, 0 makes a true statement. So here 0, 0 shaded, here 0, 0 is not shaded, so it's got to be red or green. Well, we know it should be open circles and dotted, but it's hard to see from these pictures right now. So let's look for the intercepts. So my x-intercept would be 16, and my y-intercept would be 4. So up here, it looks like y-intercept could be 4. Looks like it could be 4, but an x-intercept of 16, this is nowhere near x-intercept of 16, so it'd have to be the red one. I think we already did this one. Y is less than 2x. Yeah, we did this page. Negative 1/3, we did that. Okay, so it's like we did all these. Or maybe we didn't get to these last two, so let's do them. Okay, so here we know 0, 0 is shaded, so 0, 0 should be true statement. Oh, we did do this one above. Okay. For this last one, we also did that. Okay, so we're good. We did everything.